Hey everybody, Matt Wallace bringing you AI every day. I am super excited today to talk to you about some experimentation I've done with CodeLlama and variants of CodeLlama. So you've got Llama 2. We've talked about that before. It's the meta model. It's performed extremely well for an open source model. It's available in, I believe it's 7, 13 billion, and 70 billion parameter versions. And I've talked about being able to run it locally using 4-bit quantization, which was a pretty fun experiment. I've taken this a step further because Llama also released a CodeLlama model. CodeLlama is a 34 billion parameter model that has been specifically tuned using the Llama architecture, but tuned on a lot of additional code and reinforcement learning examples for. And it actually itself came in 3 different varieties, which was a Python version, a kind of base version, and then an instruction tuned version. Now, I won't go into this on the show today, but Meta also revealed that they had unnatural problems or something, but they had trained a version of CodeLlama on purely generated examples that were meant to emulate specific hard problems and have a very specific form. And that one, the model trained on those actually in their technical readout actually outperformed the other variants of the model, but they didn't release that version, which is fascinating to me. However, some folks took and released a version of this called, I don't know if you call it Phind, but it's Phind. And it's basically a fine tuning. And they say, we fine tuned Phind CodeLlama 34B on an additional 1.5 billions of high quality programming related data and achieved a 73.8% pass that one on human eval. This is really interesting. And it's very powerful. First of all, let's get some context here. And I'm gonna have the human eval leaderboard, which I've actually showed you before on the show. But currently, the top of the human eval leaderboard, and they haven't put D1 on here yet, but the top of the human eval leaderboard is GPT-4, which is a 67% pass at one, a 0 shot. Now, there are actually 4 entries higher on the leaderboard, but they're all based on using GPT-4. So it's different sort of meta frameworks for using different sort of prompt systems and memory systems and learning outside of model training in order to enhance it. The top one is a paper called Reflections, spelled with an X, that achieves a 91% pass at one, which is incidentally incredibly high. What I did is I took the Phind CodeLlama 34B V2 model, and there was actually a V1 model, so these came out in quick succession. I took the V2 model with its 73.8% pass rate, and I downloaded the bloke who does a whole ton of quantization of models. He's basically super active in the community. He's gotten a little bit of sponsorship, and he's doing an incredible job of taking interesting and popular models and basically quantizing those so you can download pre-quantized models. So I took the highest quality version, the version that should have the best inference rate, best inference accuracy on that in the 4-bit quantized model from the bloke, which is, if you're looking it up, it's the Phind Phind CodeLlama 34B V2 GPTQ model. And I used specifically the GPTQ 4-bit 32 group act order true branch. So I went to go replicate this paper. And with that 4-bit quantization, my pass at one score was 72.6%. So that's basically 2 questions. The human eval data set is 164 programming problems. And I was able to get it to the model to produce 119 out of 164 correct versus 121 out of 164 for the main model. Now, if you're keeping track though, 65% again was the GPT-4. And so now we're so little time, right? It's in how many months? So March to September, about 6 months of time, and an open source community model that I can run on my home GPUs. And granted, I've got a lot of GPU horsepower for home, got a lot of memory. Although 34B is getting to the point where it's a lot easier, but this 4-bit quantized model that I can run at extremely good pace, I am able to achieve much better results than GPT-4 based model is. That's incredible. That is amazing to me. Now, I took it a step further beyond that, which was that I then took the GPTQ quantized model because CodeLlama is supposedly trained on longer context windows. And what the folks at Meta had stated was that it had been trained to be stable in generating tokens up to 100,000 tokens in context length, which is fascinating. What I then did, figured out some parameters, to extend the context window. And I extended it from the default, which is 4K tokens, to 16K tokens. In order to do this, as far as I can tell, you have to specify that you want to compress the positional embeddings. So I set a positional embedding compression of 4:1. And then I retested with that. And I was still able, with the GPTQ quantized version to 4 bits, and then using 4:1 positional embedding compression, still able to achieve a 71.3% pass rate. So still 6%, 7% better than GPT-4. And this model was able to digest. I actually fed it LangChain's caching file and asked it to analyze it. So I gave it 1,000 lines of code, 35,000 characters in that, and asked it to analyze it and tell me what all of the classes and methods did and et cetera. And it gave me a pretty good readout, totally sane readout. Definitely not making things up. Now, I have seen the model, especially the quantized model, when I was running it in text generation web UI, I've seen it make mistakes. Like, for example, it was modifying my code at one point, and it actually lost characters from the code. So I had a line of code, and it wasn't even trying to change this line of code. It was literally just trying to reprint it, and it literally printed it with characters missing. It actually was the model name in my file, because I was having it tweak the web service that I wrote to basically put an API in front of this so I could properly do the human eval inference. So it's not perfect, of course, but 71.3 pass at 1 speaks for itself. Now, granted, too, I don't know how much this changes as the context window gets longer and so on. So really interesting overall, these tests. And I think it goes to show how incredibly far open source models are coming. So I've got some more on this that I'm going to do. And I think that I might have a very exciting update to share in the future, because we're not done yet. There's some really interesting things that I think can be done that really go after what the pinnacle of state of the art is. And so I'm going to be going after it just because I want to, because it's super fun. But really amazing to see how far open source models have come. And by the way, for those of you who are following the show regularly, of course, I've done a couple episodes now on my free range GPT plugin. I have to say, I flip it on once in a while, and I basically encourage it to code more stuff for itself. And it now has a full GitHub repo, and it can interact with Gmail, and it can send and receive messages on Telegram. And so in the not too distant future, I intend to make that independent and get it doing background tasks and start to really work on some of the wild versions of the agent frameworks out there, the kind of baby AGI, auto GPT type of things, where you give them much higher level objectives and they begin to use different models and different prompts to decide what the objectives should be, and then parse those objectives down to steps and carry those steps out with a wide variety of tools at their disposal. But the great thing is, I'm going to be doing this in a way where when my model starts doing that and it seems to be getting stuck, it's going to be able to send me messages on Telegram, and I'm going to be able to reply to it and give it advice no matter where I am in the world. So I'm starting to think about AI as a nexus for my activity that can be doing things independently, whether it's research or code, summarizing emails, fetching news for me, keeping me up to date, all those kinds of things in the background, and just acting intelligently, doing some kind of basic thinking for me, if you will. It doesn't take a lot of brain power to go through my email. And actually, it's quite a chore to sort through and go, is this important? Is this not important? Is it spam? Is it just unsolicited and commercial? And those things take up a lot of time. So I'm really excited about making that work, but also about being productive with, if you will, a most prosthetic for my brain as AI stuff. Really exciting news about this Phind, and I've posted my results into a discussion thread on Hugging Face in that 34B V2 GPTQ discussion thread. And I'll, of course, have some screenshots that are up for those of you who are watching it on video. But if not, I definitely encourage you to go check this out. And it's fascinating to me because, as I've said many times, everything going on in the AI space right now is moving at absolutely breakneck speed. And if you think about what it means to have a model that can write code potentially better than GPT-4, which was already no slouch, and be able to do it completely independently at a microscopic fraction of the cost. And of course, for me, the cards are in my system. I use them for other things anyways. I actually, boot into Windows sometimes and play games. But if I'm not, and I could just run the 23 hours or whatever I'm not gaming on an average day, the idea that it can spend 160 hours a week thinking, summarizing, researching, writing code, and just giving me readouts and taking direction starts to really blow my mind. And if Steve Jobs called the computer the bicycle for our mind, I was saying for a while, I felt like AI was the real bicycle. And I'm starting to feel like it's more like AI is almost like the self-driving car, or maybe like a self-driving combine, like the folks in AI-empowered agriculture are making now. Just go do this job and let me not do it because I can use my time more effectively elsewhere. So really exciting stuff. And I will try to cover this more in the future as we get towards cracking even higher rungs on that human eval leaderboard. Have a great one.